For our time series end-to-end project, first we'll create a new project and we'll start from scratch. I'm creating a new project. Yeah, the project is now created. So I'll select this as my project and I'll go to IAM and admin. Inside that I'll go to service accounts. Now I'll create a new service account with the following permissions. You can name your service account anything. I'll name it as time series. Click on create and continue. We need to give 5 roles based on the readme file that is there: storage admin, vertex A admin, AI platform admin, artifact registry administrator, and service account admin. Let me give this. So once you have given all the roles, vertex A, storage admin, AI platform admin, artifact admin, and service admin, click on continue and click on done. So once you have created this, go to the 3 dots, click on manage keys, click on add key, and you'll create a new key to download a JSON file. Once the JSON file is downloaded, I'll open this, and we need 2 things from here that you should change in your env file. First thing is copy the email ID. And go to your env file, and inside the env file you need to create all these based on your bucket name and the container names. For now, just follow these steps. Replace the service account email with the email that you copied just now, and the project ID would be the one. You can copy it from the cloud console. So once you're done, later you need to replace these xxx with the folder names. For now, just follow this and just a copy, create a env file with AAP health root as ping predict, and replace the project ID with your project ID. Select the region as US East 1, and for right now, just keep these, and later we'll replace based on your bucket name. So once this is done, save your env file, and right now what you'll do is you need to activate the service account. For that, first type in the command gcloud auth login, choose the account based on your email ID. So once you're authenticated, now you need to set the project ID. Right now the project ID is some other thing, so to set your correct project ID you need to run gcloud config set project. My project ID is mlops time series. Yeah, it says updated property. So once this is done, you type in the command gcloud auth application hyphen default login. Again do the same step. Once this is done, you need to activate the service account where you downloaded the JSON file. For that command, type in gcloud auth activate hyphen service hyphen account hyphen key hyphen file equals. You need to copy the JSON file path where you have downloaded the key. Make sure you give the location in double quotes. We can see it says activated service account. So once this is done, you can run the file data preprocess py file, which is located inside the src. Before that, you need to create a bucket for your project. So go to the three dots, click on cloud storage, create a new bucket. I'm naming my bucket as mlops __ fall 2023. Since this name is already taken, I would give triple underscores. For the region, you can select as UST East 1, and for this click on continue, and click on create. So once you created the bucket, create a new folder called data and go inside that, and you download the file from the readme that is given over here. You can download the data from here in this location and upload the Excel file inside this data directory. Once the file is successfully uploaded, now you can go back to the VS Code and you can run this file. Make sure you have to change the bucket names in this. So I have changed the bucket names inside this file. Make sure you replace the bucket name based on your project, and go to the env file and make sure you update the bucket name inside this also. And yeah, right now this is fine. We'll click on save and we'll save this file also, and we'll run python data preprocess.py. You can see the file is successfully run now. You can go inside the bucket name and see, you can see the JSON file is created based on the training data. And if I refresh this, you can see the train and test folders are created with the corresponding Excel files. So once this has successfully run, you now go to Google Cloud Console and go to API and services and go to enable API and services. Here inside this, search for artifact registry API, click on enable. Once this is enabled, now search for Vertex AI API. And enable this. And also make sure you enable the Composer API. Let this run in the background. In the meantime, what we will do is we will go to dashboard and we will search for artifact registry again. Here we'll create a new repository. I'll name this as time series. I'll select the region as US East 1 and I'll click on create. So once this is done, we'll create a Docker file for the training and test serving directories. Before that, you need to configure your Google Cloud account with Docker. For that, you need to run the following command. It's gcloud auth configure hyphen docker US East 1 hyphen docker dot package dot dev. Before that, make sure Docker desktop is running. So since this is already running, I'll run this command. It says adding credentials and the credentials are updated. Once the credential is updated, you can now push files to the artifact registry that you have created. Before that, go to the env file and replace the container. No, this is fine. Like already the time series folder is there. We have created on the same name, so this is fine. Replace this XXX with the project ID. Similarly, for the model serving, replace this with the project ID and save this. And inside the Docker files of train and serve, we need to change a couple of things. First, we'll change the bucket names. Our bucket name is mlobstable_fall23 and mlobstable_fall23, and you need to change the project ID also. Save this. This is the Docker file for serve. Similarly, you need to update the Docker file for trainer. Save this, and inside the train.py file, you need to change the bucket names based on your. So this is one, and this is one. So once you have made all the changes, make sure that it's changed everywhere inside the Docker file, inside the train file. You don't need to do any changes inside the predict, and inside the serve Docker file, make sure all the changes are done. So once this is done, make sure you have saved all the files. Okay, once everything is saved, you need to give the Docker command that is like suitable for Linux and ARM devices also. So for that, follow this command. It's docker build buildx build hyphen platform linux slash amd 64 hyphen f trainer slash docker file hyphen t us hyphen east 1 hyphen docker dot pkg dot dev slash your project id, which is mlops time series for me, slash time series is the folder name that you created on the artifact registry, and you can rename your image as trainer colon v1 slash dot hyphen load. Make sure to run this file inside the src directory. This will create a docker image, and this runs for some time.
Meanwhile, while the image gets built, let's try to create the composer for our Airflow environment. So firstly, we'll start by enabling the Cloud Composer, which Dhanush has already done. So in the Cloud Composer, which is already enabled, I'm sorry, let me change the file. Yeah. In the Composer, so since the composer is already enabled, let's try to create a new environment. Here we have the options of the composer 1 and the composer 2, where the composer 2 comes with the auto scaling and supports airflow 2, which we'll choose that. And here we can name the environment to be anything. Now let's try to name it as mlops, and the location can be anything, but we'll choose for US East 1 to match all the locations of the rest of the project. And for the image version, with the options that we have, try to choose the latest image version since it supports everything. And for the service account, try to grant the access, and if you're not getting the option of granting the access, make sure that the cloud compose engine has the access of the editor role to it. Okay, let me grant the access, and depending upon your project requirement, choose the resources that are required and also the configurations. And for now, since our project is simple, the workload is also very less, I am choosing the small environment resources and click on create. So for this environment to create, it will take nearly 15 to 20 minutes. So now let's get back to building up the image.
The image is now built successfully. Now we'll push this image to the Docker registry. For this, follow the command docker push US East 1 docker dot package dot dev /mlops time series, which is your project ID, /time series /trainer :v1. So this will push the image to the Docker registry so that we can use it for our training and prediction purposes. This is pushed. Now we'll follow the same for the serving. Inside this you need to change serve, need to change the folder name, which is serve, and you need to update the image name. Right. So once this is done, there is a syntax error where the project ID is mlops time series. Let's debug this. Docker build x build platform serve docker file mlops time series. Okay, let's go to the docker file of serve. Oh, okay. Here the equal to is, just make sure there is no space after the equal symbol. We'll just clear this out and we'll run the command. So now this has built successfully. Now we'll push to Docker registry. We'll just change this to serve. Now all the images are pushed to the artifact registry. Now you can run the build script, which will push the training and serving container images, and it will create the job in the Vertex AI. Before that, you need to install grpcio with the version of 1.51.3, which is suitable with all the devices. Since we have already installed this, now we'll run the build script. As we can see, if you have followed all these steps, the training would have started by now, and like you can go to the Vertex API and see the process. Here, let's search for Vertex API. And if you go to the training, it's taking some time, I guess. Let's see. Let's refresh this. Maybe, yeah, it's under US East 1, that's why it's not showing. You can see the status is training. After this, training and building the image would take around roughly 20 minutes, so be patient, and if you have followed all these steps, you would get the model saved, and this this would be deployed to an endpoint.
So now since the model is being deployed in the Vertex API, we can check it from the Vertex AI, and under the Vertex AI you can just get into the online prediction and you can see our model being which is deployed with the endpoint. And if you go in and if you go for the sample request, and it gives you the format in which the data has to be given as an input for the model. And now to ensure the continuous improvement and update of the model, we'll implement a pipeline using the Apache Airflow, and we'll program this to initiate the retraining process of the model daily at the 9 p.m. So as we have created the composer environment before, now we'll try to add up the required packages for our project. So which will be scikit-learn, numpy, joblib, openpyxl, and python.env. So once if you have given all the packages with their required versions, and if you click on continue, it will take another 15 to 20 minutes for the model to the environment to get updated. And meanwhile, let's walk through our DAG that we have written. So the DAG, we have designed the DAG to initiate the retraining process of the model daily at the 9 p.m. and for which we try to get the preprocess script and the train script from the GitHub URL, and we try to store it in the cloud's local storage, which we access using the temp. For the instance, the model, the cloud storage stores the script in the preprocess.py, which resides in the temp folder, and same goes for the train folder also. And we use the bash operators to fetch the script from the GitHub and store it in the cloud storage in the local temporary storage. And we schedule the interval for 9 p.m. every day to retrain the model. And then we have the bash operator to run the preprocess script and also the bash operator to run the train script. And we set up the dependencies of pulling the preprocess script first, followed by the train script pulling, and then running the preprocess script, and followed by running the train script. So once if you have defined your DAG file, and also you need to check whether your environment is perfectly set up with the required packages or not. So once that is done, in the environment you can get into your DAGs folder, and initially you'll be given the airflow monitoring.py DAG, which is by default given by the cloud. Here you can upload your DAG file, so which will be training.py for us, retraining.py. So once this is updated over here, you can try to access it from the Airflow web server UI. So it will take a decent amount of time for it to reflect over here. So we can also check it over from here. So let's try to refresh this. It's taking more than expected time to get the DAG over here. Let me just re-upload our retraining.py file once again. Yeah, before doing that, we also need to update our bucket name over there. So we'll update our bucket name over here and we'll upload the updated file. We'll overwrite it. And now let's check if it's getting reflected. Yeah. Since this is reflected, we can access it from the Airflow web server UI. Okay. So as you can see, out of the 4 processes that we have, first one is to pull the data preprocess script and then the train script and then to run them in the sequence. Out of the 4, 3 have been successfully done and the last process is getting done, and as you can see all the 4 processes have been successfully done, and we can check it from the buckets. So if we go into our MLOps fall 2023 in the model, you can just see with the timestamp of 205812 a new model has been deployed over here. So that's it. And also make sure to have a financial control and optimize the resource allocation, and also set up the billing alerts to configure the system, and it's just to have enough budget throughout the duration of the project.